What I'd like to talk about today, the title of the presentation, The Convergence of Nonprofit Initiatives to the Benefit of the Lubricant Condition Monitoring Industry. Really what this means is that I've been around long enough that I've seen quite a bit of progression in our industry, or some changes, and I'd like to comment on those changes and basically comment how we as volunteers are contributing to this, and how the energy of our contributions are actually helping us build a better, stronger industry, build more depth in our industry. So I'm actually pretty excited about that. So let's go ahead and get into it. One thing about being in the industry as long as I have been is that I've actually had an opportunity to see the way things were. So the first job that I had, I literally had a job where they passed out yellow pads of paper. We had pens in our desk. And when we wrote something up, we wrote it up on paper. We gave it to the boss. He commented with red marker, gave it back. We incorporated the comments once. It went to the typing pool. The thought of a computer back then was almost a novelty. That was back in the day when the Apple towers with about a 4 by 6 foot black and white screen were the rage. That was as good as it get. I'd love to have half a dozen of those to sell on the market now. But when I got to my current job, where we were is really represented by this picture. We did have telephones that we had to hold to our ears. We had one in a house. We had one in an office if we were lucky. And we had the dial-up modem. So with these tools, we really, and they were marvelous in their time, but they really don't compare very well to what we have today. And I'll comment that the progression in general of our industry, the depth of our people also doesn't compare very well today to what we had back then. We're much, much better. Okay, so I'm going to go ahead and read this first bullet because it's significant to the argument I'm trying to make today. And that would be that while technical innovation has clearly enhanced and helped develop our industry, I would argue that the volunteer efforts of our practitioners has had an equal or greater impact in how our professionalism is perceived and in the contributions we are able to make to our respective organizations. I've long been a believer that the tools that we have are marvelous and helpful, but if we don't have the right people to exercise the tools and to implement them and to basically become champions within the organization, the tools are of lesser importance. So thinking back to my time, I'd like to focus on 3 nonprofits. I will comment that there are others that also have contributed greatly, and I don't intend to minimize any other contributions, but I'm picking on these 3 because these are the 3 that I'm most familiar with. So the 3 that I'd like to discuss to some degree here in the rest of this presentation would be STLE, the Society of Tribologists and Lubrication Engineers. This particular group is a professional society. It's a place where people within the lube industry can meet, have an annual meeting, have a conference, they have trainings, and lots of good programs. That would be one of the 3. The second would be ASTM International. I've had involvement with ASTM, and it's actually been quite marvelous, but this organization is different than STLE in that its purpose, its charter, is to write standards, trying to provide an anchor to the information we have in the industry. And the third one I'd like to talk about is ICML, the International Council for Machinery Lubrication. This group is a certification organization, basically to help the practitioners have a way to demonstrate their knowledge and their skills. So we'll continue on. First off with STLE. So when I got into this industry, I attended my first STLE meeting a few months after joining my current company. And the buzz at the time was the Certified Lubrication Specialist exam. And what STLE had very correctly identified was that the professional within the lube industry wasn't getting their due as other professionals in other industries might have. And I'll use the mechanic in the plant as an example of this. It wasn't too long ago that a new person coming up in maintenance would be given the job to go and grease all the motors and to change the oil and to do that type of an activity. And that was an entry position, and that was a position that they were pretty eager to get out of so they could get into real mechanics work. And that's how they perceived it, and that's how management perceived it as a less valuable option. Now, I would also argue that the lubrication engineer, someone like myself, also had a similar bias within the engineering world. Oh, it's just lubricants. And I think that was a common perception. So STLE, and this was over 30 years ago, they were just rolling their test out when I got into this. They developed the certified lubrication specialist as a way for the experts in the industry to be able to say, hey, I can do it. I've been certified by somebody as having knowledge to contribute to the organization. I think this was a start. I think this was a very important piece in bringing a level of professionalism to those that were practicing what we do. And kind of interestingly enough, to further this argument, I went to their webpage a week or so ago and thought I would see what they say about the lubrication specialist. And within their webpage, they say to become CLS certified to increase their credibility and standards. So STLE today still acknowledges that the certification has value in increasing the credibility of the practitioner. I think this is kind of interesting 30 years later that we still deal with this particular battle. Okay, so this particular certification happened because STLE provided a forum or platform where experts could meet and experts could pool their knowledge and develop a product. So it took volunteers. Okay, so I'm thinking back in time again to ASTM. I joined ASTM early in my career. I did it because we installed an on-site oil laboratory, and I felt because we were trying to do ASTM type standards that I should probably better understand what they were and be involved in those kind of groups. When I arrived at ASTM, I learned that ASTM had one single standard that was related to condition monitoring, ASTM D4378. This was on turbine oil monitoring. It provided programmatic type information, and that was it. That was as far as it got. I was part of a group that developed the second standard, D6224, condition monitoring of auxiliary equipment of power plant, and this really is a very, very cool document, because it's a roadmap how any industrial facility could manage its oil condition monitoring program. That was put on the books about 25 years ago. So the thing about this that's kind of interesting is that at the time, if you contracted a laboratory to do your testing, that laboratory would tell you that and you ask them, are you doing ASTM tests? They would say, well, we do ASTM-like tests. And that doesn't mean they weren't doing the best job they could or they weren't providing a high level of value. That just means that they weren't able to do ASTM tests on condition monitoring or in-service lubricants simply because there weren't any. And so what they were doing was taking the tests available, and then the tests at that time were written exclusively to sell new lubricants. So if you go to the internet and you type in your favorite lube, you're going to get a product data sheet, and the product data sheet will list a half a dozen or more tests, and that would basically be the vendor's way of saying this is what my product will do, and that's what we had. And so we used those same tests at the time to test the in-service or used oils. Those tests had not been vetted for in-service lubricants. So in fact, they weren't, they were, it was appropriate to try to use them, but they were not quite what they might have been. That was our baseline. And the third organization that I want to talk about is ICML, the International Council for Machinery Lubrication. So 30 years ago, ICML did not exist. It was incorporated in 2001. And so this is actually a very, very important organization and platform to our industry. And 30 years ago, they weren't there. So the changes that have occurred within our professionalism, within the development of our people, really have slowly increased over the years, and let's talk a little bit more about those. So since the time of the CLS test, 30 years back, STLD has introduced additional certifications, oil monitoring analysis. They have 2 in that series. They recognize that the condition monitoring industry is important, and they have been working as a group to further training and knowledge and certification in that area. ASTM, when I joined 30 years ago, was ASTM American. It was very closely associated with American standards, and they have since rebranded themselves to ASTM International, with the acronym just being the name, and have become a much larger global presence. So since those first 2 standards all those years ago, dozens and dozens of new standards have been developed. Existing standards have been modified to include condition monitoring. In fact, the condition monitoring subcommittee that does all this, they are over 200 people strong. So at the twice annual meetings, 50 to 60 practitioners assemble and discuss standards and discuss industry initiatives. So ASTM has provided a platform for those involved with testing to assemble twice a year and to improve the quality of their business, to identify their needs, and to go after projects that make data better. And really that's what ASTM has done for us, twofold: provide a platform and also to take our condition monitoring data and make it better. So the ICML, their contribution since they came online has been in to certify individuals over a broad range of topics and knowledge areas to demonstrate to employers, to the world, to the market, that they know what they're doing. A very, very important part of our industry. So look back in TAM standards a little bit. So a test standards are not all the same. They a particular topic could have several standards that are designed for it that are all different. They may measure the same particles in an oil sample, but they measure the particles in a different way. And because of that, the data that they produce isn't going to match necessarily. It could. And so basically what I'm saying is that the different test methods do introduce a bias between themselves. These different test methods also have different levels of accuracy or precision. So a couple of the prime ones, emission spectroscopy and ICP spectroscopy, these are workhorses in the condition monitoring industry, and they are different technologies or techniques. They actually are able to test different sizes of particles, and they test them in different ways. So they will produce somewhat different data. So I have a list of several of these standards to the right side, and this is just on wear metals. So if you as an end user of data desire to have wear type data, in fact, as you learn more, you would want to look into all of these standards, perhaps others, or raise the question with your service provider what their recommendations are, because there are different values and different costs associated with each of these. Now some of these tests are used commercially because they're able to be performed at a higher throughput level, which produces a lower net customer cost. So this is kind of another interesting point, and that would be that the cost generally, one would think that if it's more expensive, it's probably better. Not necessarily true. And what is better? And what I would argue with that is that as an end user, it's good to know what level of precision and data that you need. And it's also good to be careful and make sure that one doesn't overbuy the data that they're getting. The level of precision that one pays for might be much better that is actually needed for the purpose. So in my bullet list, I'm commenting about this. You know, basically what we would want would be a high level of repeatability. We'd like the data to come in similarly from sample to sample to make sure that it's useful for trending, but we also want to make sure that it's accurate. Okay, I'll move on to the next slide. Okay, so there are a couple of terms that when you get into this, as you try to vet the differences between different test types that are very important to know when you make your selections. And one would be a bias, and I'll talk about each of these three definitions because they're really important to the quality of the data that we get. So the bias may be determined as the average discrepancy between a known reference value and reported values. So it is possible to get data that is highly repetitive, but is off of the reference mark. And the problem with that would be that one might, depending upon the direction it's off, one might make overly conservative or unconservative decisions on the samples just simply because the data that's being reported is shifted to the left, the right, up or down, or whatever it might be. Repeatability, reproducibility, these are just terms that would describe the range of data that one might expect from their testing. The reproducibility important because it may be from time to time, if you have a really important sample, you might want to send it to a second laboratory for a second opinion. And if the data comes back a little different, good to know what that difference might be. So very important to understand your data, understand how it's developed, understand what it can give you, and then use that to make decisions. So an example of this would be in a condition monitoring standpoint, if one receives test data from a main turbine, a 10,000 gallon main turbine, and sees a 2 ppm increase in a wear metal, that is an entirely different issue than seeing a 2 ppm increase in wear metal in a gearbox. So the severity of condition could be enormously different, and the sensitivity of the test could become very important, less important to be spot on for the gearbox, very important for the data to be very tight and accurate on the main turbine, because if 1 or 2 ppm are important, a deviation from test to test of 2 or 3 ppm could give false information. So I have an illustration that talks about data accuracy and bias, and I think this is a very, has a high level of, or is very illustrative. So if you look in the upper right corner, this is the data that we would all like to have. Now the spread of the data points that you see in that bullseye, and I think this is a very good depiction of it, this could be based upon how accurate the instrument is in and of itself. So that may be a little bit bigger or smaller, but ideally we would want all of our data to sit in that quadrant. So we could have, if you look to the upper left-hand side, we can have a very tight grouping of data, but it's off-center. And so this very tight grouping of data off-center to the upper corner sent to another lab that also had a large bias in their data could be in the opposite corner, and the test data could become very misleading. So large bias, low precision, low accuracy. You can see in the bottom two how we have quite a bit of data scatter. So actually, even everything except for the upper right-hand corner are bad, low accuracy, and that upper left-hand corner could be very misleading because the practitioner might think they have very good data when in fact they have very low quality data. Something to be careful of. Okay, so as kind of a final slide in the ASTM area, these are some of the standards that the subcommittee has generated. You can see that we have the 6224 and the 4378 on this list. but also several other guides. Guides and practices provide a lot of good baseline information for somebody setting up a program. These documents would be very, very valuable. They would provide a roadmap and how to do it and how to apply the information. There are other guides that are being worked on within the condition monitoring group. One of these that I think will be very important, one of the prime areas that we do testing would be in the diesel engines in the transport industry. That's a significant part of the condition monitoring industry. And ASTM is currently writing a guide on how to do that, what to do with that. I think when that's issued, that will be extraordinarily valuable. Chemistry is another area that I've got highlighted that ASTM has been active in. So for this example, I basically focused on FTIR. I believe FTIR is a very, very useful, valuable, very encompassing tool to demonstrate the usability of a used oil. And I've listed several standards. Of course, there are many other ASTM standards that relate to the chemistry of the lubricant that are also very important. So I'm giving you a snapshot. Test methods. The first one on this list, I think, is actually an area of opportunity within our industry. Most of our lubrication is done with grease. Most of our testing is done on oil. Of course, our large machinery has large volumes of oil relative to the volumes of the grease, so that is natural that would have gone that way. But the grease testing industry, I believe, is a great opportunity for our community, our industry to get better, simply because most of the applications, most of the conditions that we could monitor would likely start from grease as a starting point. Varnish and oil. Varnish has become incredibly important to the industry in the last 20 years. With the change in formulations of oil, there was a major processing change in how oils were built. It also opened the door to varnishing issues that weren't there 25 years ago. And so we have the ability to measure and monitor that, also very important. Okay, so a little bit on so this is from their webpage a few days ago, and I did a screen grab. And what I'd like to show you is that they have a tool on their webpage that you can go to where you can find where certification tests are being held. So if you look at the list, this list is global. It's virtually all parts of the world. So the ICML has gone from a nothing to something that has a presence in several different languages across the globe, and will hold in-person tests. So as an end user, one could go to this website and pick a test. You see their sponsor names. You can find trainers with this, or any other means that you might want to find the trainer, but the certifications are available in this manner. Also, a few months ago, partially in response to the virus, ICML has built an online testing process, a platform where the end user can actually go into that and take an ICML test in the comfort of their home. So kind of a cool thing. In the upper right-hand corner, I'm featuring one of their certifications, the Machinery Lubrication Engineer, the MLE certification. So ICML basically took the CLS concept one step further, aimed at the engineer in the industrial facility to provide a demonstration of a high competency across a very, very broad range of skills that the engineer in an industrial facility would need to have to be successful for their organization. So something else that some of you might have some interest in. So ICML is expanding its value. ICML 55 is its first attempt at a standard. ISO 55000 is one of the current, more recent focus areas of the ISO suite of similar standards, and it focuses on asset management. ICML took that concept and built a standard using the ISO 55,000 requirements aimed right at an industrial facility, and looked at lubrication assets. Now, when you think of lubrication assets in an industrial environment, you might think of machinery, and obviously that's a big part of it. But in fact, the asset of a lubrication program, so think in terms of a lubrication program, are much, much larger than just the machine. And very important to have a program that accounts for all of these. Very easy to focus on aspects of a program that would limit an organization's effectiveness, because in reality, any of the 12 areas that ICML has identified that is weak could bring a program down. So this particular product, it provides a roadmap and a way for the industry to define what a good lubrication program looks like, what elements need to be strong, and how eventually, I believe, will grow into a product that will be usable and useful in taking lubrication programs up to the next level. And as we all know, a strong lubrication program in an industrial facility saves money, and this is a highly valuable tool. So I'll drill down a little bit in this. I'm not going to spend a lot of time with it. I don't have that amount of time in the presentation, but these are 4 of the 12. So in terms of an asset of an industrial facility, people are an asset. And I've made the comment that the volunteers have been vital to improving the professionalism and the capability of our lubrication programs globally, and have helped us greatly. Also true at the plant level. So to make a program work, we can put in processes, we can put in expensive tools, we can buy expensive instruments, but if we don't have the people to run that, and don't have the people to manage it, and add the additional knowledge that we all have, the program won't work very well. So many years ago, and this is something that still kind of sticks with me, I met some individuals from a coal power plant, and they had a fleet of 5 coal power plants. They had a condition monitoring program, which included lube analysis, and they commented to me that over the previous 4 or 5 years, in fact, they were considering canceling their lubrication condition monitoring program, because over the previous 4 or 5 years, they hadn't found a single thing wrong in any of their plants. So if you can imagine 5 coal power plants with an active condition monitoring program that is not able to find a single problem in 5 years, one can imagine that the program wasn't effective. And so this is just a very strong example of what can go wrong if the assets aren't managed top to bottom, and if the people part is missing. So I mentioned lubricant condition monitoring, which is one of the 12 elements. System design of equipment. So as we get deeper into equipment, there are better and lesser ways to have the machine configured in terms of sampling, in terms of changing the oil, access to people, safety. All those kind of things play a role in how well the machine is maintained. If we can't get to it, it's hard to maintain. If it's hard to get to, the people may be more reluctant to go in and maintain it. And then the 4th one I have here would be tasks. It's just really important to be organized and have a plan in place. And this talks to a maintenance plan and how the maintenance plan is implemented. These would be 4 of the 12 elements. So within the ICML 55 product, one can do a deep dive and get different attributes that are important to help one build a better program. Okay, so some takeaways from my presentation. So 30 years ago, I don't think there was an awful lot of help out there for the lubrication practitioner. A dear friend of mine explained to me that when he broke into the industry, and this would have been maybe 40 years ago, the company that he got a job with, he spent his first year in training. They had an extensive in-house training of their lubrication engineers to ensure that they had a high level of knowledge, so that when they went out and worked with the customers, they could help their customers. And I believe at the time, and 30 years ago would also be true, that the primary knowledge holders within our industry were those people. Yeah, we had university people, we had an occasional industry person that had a high knowledge, but really the knowledge was held within a very small group of trained people trained within their organizations. So since that time, that type of training I would expect would still be done to some extent. I don't know how these companies, or if these companies are looking outside to some of the things that have been developed since. But the three nonprofits that I mentioned have stepped in and provided platforms for us as end users, as practitioners, to assemble and pool our knowledge and work on common projects and simply get better. So the end result of this is that the knowledge of the plant personnel has increased. I believe that going into many industrial facilities, the technician that or the mechanic that's involved with that may not immediately be identified as the oiler or the greaser anymore. Still may do that function, but the value to the plant in doing the changing the oils, managing the cleanliness of the oils in the machine, to ensuring that the grease is installed correctly, not over greased, in the right kind of intervals to feel the pulse of the plant. The value of that function is higher. The management has come to realize that well lubricated machinery means machinery that doesn't break as often. That means higher reliability and availability of processes. So that skill has become more important because I guess it's always been as important, but the importance of it is more apparent. So this has meant an improvement in the stature of the professionals. I believe this particular meeting, this conference that the Fluid Tech has organized is an example of that. It's amazing to me to think that an organization was able to organize a presentation over the course of, when I looked at the schedule, 14, 15, 16 hours with nearly 50 presentations across whole continents, and find enough people that could even talk. 30 years ago, we wouldn't have found 50 people that could do this. There may be a handful, but it would have been about as good as we could do. And here yet today, we have an assembled group of experts that are sharing their thoughts and opinions with a very broad host of people throughout the world. So think about how incredible that is. So this couldn't have happened without the stature of our profession improving, without our practitioners becoming more knowledgeable, simply because we wouldn't have had people or technology available to do it. Management is more aware of this value and are supporting people and helping people gain the skills. I've had a very, very supportive management team over my years, and they have encouraged me to become involved and get better. And by being involved, one does have a chance of getting better. So I think another interesting point would be what ICML is doing with their ICML 55. So this is a pivot from building a better professional with the certification of training, of the other elements that we're putting into to more of a broad-based approach to look at a program as an entity and to find some way to help the industry bring up the threshold of what good is across all of the programs. So also very good. The final point on this would be these efforts are being driven by volunteers. So there's not a company of experts that is available per se to the industry, although through volunteer platforms there is a whole cadre of people that are involved, that are available to the industry at large, that help us get better and stronger. So a few guesses on what's next. I would guess that in the next 30 years, we're going to move further away from where we are today than we did to move from the cable modem days to today. I think that the progress of change is here. It's going to get stronger. Digitization is a big part about that. I believe that expert rules are going to become much more common in condition monitoring. They're going to be broadly available to the people that do it. There's a caution with this, and the caution would be if the rules become really good and the practitioner's skill level or understanding of the rules becomes less, then I think overall the quality of programs might suffer. So I would expect that the three organizations that I highlighted are going to continue to provide additional value and knowledge. And the final point, one of the things that has been very important to me over the last several years would be the impact of the environment on our profession. You can see this very strongly in Europe. Europe with its various rules and how chemistries are handled and managed. I think that the REACH program is how they term it. That has carried throughout the world, and those rules have changed how our lubricant manufacturers are blending their lubricants, how they're distributing them, how they're what materials they're sourcing, and I believe this is a starting point that forces change. So as regulations change and in part response to emergencies that we have from an environmental standpoint, climate change and so forth, efficiencies, I believe this will also continue to become much more important. I very strongly believe that we are in a unique position as an industry. And if you think in terms of mitigating friction being one of the prime things that lubricants are able to do, if we as lubrication engineers, as blenders and plants are able to build better products, are able to specify better products, are able to ensure that the right product goes in the right machine, doing so is going to do two things. One thing is going to reduce the load in the machine. It's going to reduce the energy requirements of the machine. It's going to result in machines lasting longer. And if you think in terms of our global carbon footprint, if the lube industry is able to defer 1 or 2%, and I believe the lube industry acting as a group does have the capability of doing so, that this makes an absolutely enormous difference. So I hope that we'll always keep that in the back of our mind. So that's what I have. I'd like to thank Fluidtech. I'd like to thank the conference for the opportunity to share some thoughts with you. Greg for his kind invitation and helping me get through the technical issues that we had. And so that's what I have. So I'll turn it back over to Greg. Thank you.